Hello my friends, welcome again to my video channel. Today we will continue our work, or better said start with the work on the Drake TR7. In part 1 we have only checked what to do, and we have seen there is something to do, and I assume there's more to do than we have seen in part 1. So let's start. The first step will be to take out all boards, TR7 and all the other boards which are here located, IF chain and transmit exciter and so on. I will also take out the high and low pass filter boards to clean the contacts, and maybe we have a problem here in the relay switching. With the relay there's a transistor in series which activates the relay. The owner told me he has a problem, and I have also seen this problem, but only for one time. Then I reseated the relay. Maybe problem is now cured, I don't believe. So this part I will take also out. This one, everything here, I see 2 screws are missing. This is not good because the shield needs a very good ground connection on all boards to prevent the BFO leakage and other problems. BFO leakage means that the BFO spits into the IF chain, and then it causes the S-meter deflection without signal. Here are 2 screws missing. It's also bad because the shield also should be connected here to the chassis for better grounding. I'm curious what's expecting me inside. Another topic, I checked it with the owner and I cleared it. There is a connection here for the external counter option. We can use this input here in the position extern as a counter input, and on the display we can count the frequency here. It's not useful, it's more or less useless, so I will delete this option, and the owner agrees. So I will delete this wire. I only have to simulate the position of the switch here on the input, but I will do it with only with a wire, small wire instead of the plug. And the connector here and the switch I will remove and take a plate or so. Maybe I set in a new cinch box, cinch connector. It was a German word. Cinch connector as an optional input for any other purpose, maybe. Well, but first we will take out the modules. The shielding is removed. When taking out the boards, it's necessary to have such a hook. I made it myself, bent it from the steel wire of a cloth hanger. You get sometimes, we have here 4 filters installed. Don't know exactly which types, but obviously there's also an EM filter, no resistor inside. This could be the noise blanket. The noise blanket here is not installed. There's only a dummy board in it for transmit and receive switching, 3 or 4 pin diodes and some inductors only for switching RX and TX. But that's not so important. The noise blanket is not so good in the 7 line, because the 7 line has a rather narrow roofing filter. The first filter on 40 megahertz is a rather narrow filter, I think 10 kilohertz or so. And this has a disadvantage that any noise coming in is delayed, is broadened, and the noise blanket cannot operate properly with such a broadened pulse. It needs a pulse with a high frequency bandwidth. So the old receivers like the Drake R4C and other ones which have a broad input have better noise blankers, but a small roofing filter of course has an advantage of a better behavior of the receiver. Okay, let's take out the boards and then see what happens. We have here 500 Hertz, 1.8 kilohertz, 6 kilohertz. That's the AM filter, 6 kilohertz, and here we have 2.3 kilohertz. SSB, narrow SSB, CW, and AM filter. And this is also an original Drake filter here, not any other brand, but it looks as it has been added later. It's a different shape, but that does not matter. Okay, we can take it out. This has to be unplugged. And here we can unplug also this board from the IF amplifier. These connectors are very ugly. Don't like them. Here is the next one. Okay. This is a passband tuning and reference frequency board. And here we have the IF board. This is the first part, to take out the TR7 board and the other boards underneath, and also the PTO. It's necessary to take off the front panel and swing it down a little bit. For this purpose, first we have to take out or remove the band selector knob. And then we can loosen 4 screws on the side. For this I have to remove first the end caps. And here we can see that they are not identical. These end caps are in the wrong place. There a chance of 50% to be right or left or wrong. And the wrong side has 1, so we have the wrong 50%. Because we can see that this side cap here is better when we align it, and we can see here they are not identical. That is important. So now we loosen these 3 screws on both sides, and then we can flip around the front panel. There's another screw missing. Someone was in there who was eating screws. Okay. Now we can move the front panel a little bit forward. It's necessary to have such a support here, so we can later flip it down. But in the moment it's not possible because the PTO is blocked by the TR7. We have to unplug the TR7. There are several plugs. This one we will not need any longer. Here is a power supply, another power supply, another plug, and this wire, which goes to the, I think, to the converter from the low pass and high pass filter. And here is another connector, and this one which goes through this rubber. Okay, careful not to break it. loosen one screw. As you see, I'm rather familiar with it. I don't do it my first time. And then you can carefully flip it up. There are pins connecting to the boards here, and here also 3. Yes, these are here. Now they are rather free, and we can use our hook to rise it carefully. There's always a danger to damage the wires. That's it. That is it. Okay. These pins have to be soldered here and also on the lower side. These plastic caps have to be pinched off, and then they have to be resoldered. Okay, the PTO seems to work. Don't know the exact problem. But now we take also out all these boards. These screws are all in there. That's good. This is a voltage stabilizer. This is another one. Okay, let's start here. There are 2 additional screws which have to be removed. This is a range 5.5 millimeter. That's good enough. These 2 nuts, of course nuts, not screws. There are 2 washers. There's a screw, I have forgotten. Good morning, sir, good morning. These tooth washers are rather rusty. I think this transceiver comes from an environment with some humidity in the air. It comes from close to an ocean. Maybe there was air pollution with salt water or so. There are some signs of corrosion outside and also inside. But as it looks, the electronic is not affected, only the chassis. But this is not a big problem. Okay. This one has to be loosened. Okay. Now it's easier. You see there is no auxiliary 7 board installed, which should be there. By the way, the modification we have seen on the lower side with a lot of diodes, I will also remove. The owner told me he's not interested in receiving broadcast, AM broadcast, in the bands below 1.5 megahertz. So I will remove this option, and maybe we can later add an AUX7, or there are some artificial AUX7 boards on the market. Simplified ones could also help, but now I will take out these boards. The next board is the power supply board, stabilizer board. These ports are used to set the modes, the DFO frequencies for various modes: AM, RTTY, CW, LSB, SSB, USB, and the 10 volt stabilization. These ports are very touchy. They are on the top of the transceiver and can be rather easily touched and detuned. I will replace them by such 10 turn pots, which are safe against any touching. Okay, let's take it out. For this purpose I have to uninstall 2 transistors. They are mounted on the side panel for better cooling, and then I can take it out. The power supply board is out. The 2 transistors, we can see one is isolated with a mica, but that's not the topic in the moment. You see this? We have a burnt contact. It is the 4th from the right side. It looks rather good. I have to check it on the rear side, but this is a sign of overheating. Not nice. Full contact. It is damaged, as I see. I fear I have to take it out and replace it. I have some contacts spare and I have to clean it, because when I have a look into it, into this row, this burnt contact here shows me that there is a gap. I have to look for the contact which it is, but doesn't matter, it has to go anyhow. No discussion. And while I was checking the board, I've seen this. The fuse is blown by any reason, and the hero, it's a kind word to say a hero. I have other words in mind, don't say it. Simply bridge the fuse. No more comment, no further comment necessary. I have a bag with some Drake stuff. I'm like a squirrel. I don't throw away anything. When Drake is the name, I collect it. And I found this. 6 pins. Okay, it's not necessary to have 6 pins. These pins can rather easily be taken out and replaced, but I will replace also, it's better the plastic, because this plastic is burnt and I don't know how good it is, how good the pressure is, so I will replace these 6 pins here by this one. Of course I keep this one because the pins, at least 5, are okay. For my next repair I can take them out, but this has to go, and I will set in this one. Just to check the damaged pin, I place the board over the layout drawing in the manual, service manual, and we see this is pin 21-12-11-10-9, and 9 is the input. That is the input of the 11 to 16 volt DC input. That's a power supply for the whole power board. This is obvious that it is a little bit overloaded here, so that's the reason for the overheating. Some may smile about these board holders. I found they are useful for such works, so I don't damage the components on the top side. completely free. Okay. That's it. Now it is out. And I will swap the new one in. Okay, squeeze it down. Switch this off, switch this other on. And while the soldering iron is heating up, I can have a check of the contact. Okay, the counter contact seems to be okay. Only the plastic is black. On the internal side also, I have to check the pin, the counter pin, but this contact is obviously not burned. Okay, still seems to be good, but the problem is the plastic is melted and it is not strong enough to squeeze the contact together, so the problem is not solved when I use it or clean it. This one has to go. And now I can resolder it. That's an easy job. The other pins are okay. So I can say this job is done, and now we can focus on the trim pots. I will come back later to the problem of the overheated contact. Maybe one of the capacitors here are leaky, because the fuse which is in series with this pin is this fuse which was replaced, or not replaced. 5 amp fuse. 5 amp fuse is blown. Maybe it's caused by a short circuit during some work on the transceiver. This will happen rather easily, but maybe we have here a short circuit and on one of the caps, the this tantalum cap and this electrolytic cap is in parallel with this pin here behind these transistors. One of them is a 10 volt stabilization transistor. I think there is this one. And when there's a short here or here, then the transistor draws more and more current. This could cause the fuse being blown. So I will check this and this capacitor, whether they are okay. I don't know whether this was the reason, it's just an assumption, but could be, why not? But I will come back to it later. First I will swap the pots. I took them out, as you see, and the new ones can be set in. We have only one problem with the 10 volt regulation. When I set the pot in, then the screw is on the wrong side. I need it this way. These can be equipped, but here I have to move the pin to the top side and do an auxiliary wiring. The problem is I have to swap this pin to there, but there's a wire, a trace. I cut the trace, I have to do a bridge over it, and then I can drill a hole in it and to install the pot, which I will do now, and then a short wire is installed, soldered in as a bridge. think this will be enough. Let's check it. There's the hole. Yes. It's a little bit tricky if the resistors are okay, but I can install it this way and bend the center pin down. This will fit. Now I will install a wire. The new pots are in place. Looks a little bit ugly, but the resistors we have here prevent a perfect soldering. Doesn't matter. Here is the bridge we talked about. I took out meanwhile this capacitor here. One of the electrolytic should have 220 microfarad. It is rated with 16 volt, a little bit narrow, a little bit small for the 10 volt. So I think I will replace it, but first I check it. And the other one is this tantalum capacitor. First I will check, sorry, I will check this capacitor. At 120 Hertz, I'm measuring 190 microfarad instead of 220. The quality is okay. At 1 kilohertz, 150 microfarad. With bad quality, only 2.5. D is a dissipation factor, or tangents delta, and the quality is inverse. I will take a new one. The new one has 205, 206 microfarad at 100 Hertz. Quality is 12. At 1 kilohertz, the capacity drops 170 microfarad. It's okay. So I will take the new one. It has a rating of 25 volt. I took out the other cap, the tantalum cap. It measures perfect. At 1 kilohertz, we have nearly 10 microfarad and a quality factor of 15. At 120 Hertz, quality of 27. So this tantalum cap is okay. I will replace it or bring it back. Not replace it, bring it back into the board. No need to swap it. Before we can bring back the board into the place, we have to check the pins. The pin number 4 from the right side, whether it is damaged or not, where it was overheated. The problem is on the rear side. If there is a problem, there's a dark spot, yes, where the contact was. So I will clean it with a contact cleaner, get it dry, and then I think I'm sure it's okay again. There's nothing which looks dangerous. Okay, a little bit gets it dirty. Well, but I will take some contact. I will wash it now, not only clean it. Take the cleaner away again, because cleaner sometimes have a residue which can cause more problems than they solve. Now let's do a first check. The board is in place, so we'll check the voltages. This is in feed 13 volt. Behind the fuse is not existing. Doesn't matter. We have a current limited power supply. I measure the output voltage. Should be 10. It is 12.5. Now I can try to set it to 10 volt with the pot. With this new pot, should be I hope it can go down to 10 volt. Okay. The other boards are not installed. I wait for the other boards. Then let's do a next check. Pin 1 is minus 5 volt. Okay, it is not stabilized. Pin 2 should be 26 volt. 31. Suspicious, suspicious. Pin 3 is ground. It is 0, it's some millivolt. But it's not okay. There is a problem. The power board is out again. We have a small test setup. Input 13 volt. Or similar, what do we measure? 12.9, that's okay. That's a ground connection. We have two grounds. Pin 1 is should be -5, it's -4, okay. This is should be 24 volt or 25 volt, 31. And here we have the voltage stabilizer, voltage regulator for this voltage. We have here the input from the rectifier. It's on the other side an oscillator with a transformer. The transformer is this one. In the output we have a rectifier and then the voltage stabilizer, which should have 20 or 26. Here's 24 MC78L24, so it should be 24 volt output. And so we can here assume an input voltage of 30 volt. And I measure the 30 volt. Oops. Stay here. We measure 30 volt. On both sides, that's the output at the diodes. (32 volt). That's the same as the input. The voltage regulator, that's a ground. The voltage regulator, okay. And that's the output. It's also 31 volt. Much too high. So this small voltage regulator, which makes it 24 volt, is bad and needs a replacement. And with this result, we are at the end of part 2. I don't have such an IC in my boxes. I have to order it. And this will be the start of the next video of part 3. Stay healthy, stay tuned. See you on this channel.